Hi class. In this lecture here, we're going to start talking about right triangle trigonometry. So this lecture is going to be your first introduction to trigonometry and its basic concepts. There's going to be a lot of information thrown at you in this lecture, and there's also going to be a ton of examples. So as you're watching this lecture, make sure to pause it as needed and take very detailed notes. Okay. So here's what we're going to work through in this lecture here. We're going to use right triangles to evaluate trigonometric functions. So I'm going to introduce the 6 basic trig functions. So intro to the 6 basic trig functions. All right, then we're going to talk about how you find function values for 30 degrees, 45 degrees, and 60 degrees. And then those are also in their radians, which is pi over 6, pi over 4, and pi over 3, respectively. Then we're going to talk about how you recognize and use fundamental identities. And then we're going to talk about how you evaluate trigonometric functions with a calculator. So have your graphing calculator handy as we go through this lecture. And then we're going to use right triangle trigonometry to solve some applied problems. So the last thing we're going to do in this lecture at the end is work some application problems. Okay. So there are 6 trigonometric functions that we're going to talk about. Okay, and these are the 6 trig functions. We have something called the sine function, which is spelled S-I-E. And when I write it in class or in our lectures here, I'm going to always abbreviate it as S-I-N, sine. And note that this is a function. Okay, so it's going to be sine of some value. Okay, so for example, when I write something like sine of pi over 4, okay, this does not mean sine times pi over 4. It says evaluate the sine function for pi over 4. All right, then we have the cosine function, which is going to be abbreviated as COS. And we have the tangent function, which is going to be abbreviated as TAN, tan. Then we have the cosecant function, which is going to be abbreviated as CSC. We have the secant function, which will be abbreviated SEC. And then the last one we have is the cotangent function, which is going to be abbreviated as COT. Okay, so we have these 6 trig functions. And what I'm going to do in class today is define them in terms of a right triangle for you. And that'll make more sense, what I said as we go through this lecture. All right, so here's how they're going to be defined. So ignore all this written over here, right here. So first off, imagine you have this right triangle here, okay, as drawn here. This is A, this is B, and this is C. So angle A here is going to be denoted with theta. So we're always going to be talking about this angle theta right here. This right here, this green side here gets lowercase a. This is the length of the side opposite our angle theta. So we have angle A here, and then opposite it is lowercase a. Then we have the right angle here, and that's going to be denoted with C. And the letter C is going to represent the length of the hypotenuse of the right triangle. Okay, obviously the length here, the hypotenuse is always opposite the right angle. And then over here we have B. And this angle here is not denoted, but this right here is this lowercase b is the length of the side opposite b, but we say it's adjacent to angle theta. Okay, so let me go through that again. Here's angle theta. This side right here is the length of the side opposite it. Okay, and then here, this side right here is the length. B is the length of the side adjacent to theta. So think of it as attached to theta. And C here, C is the length of the hypotenuse. Okay. So this is how we define the trigonometric functions. Sine of theta, so sine of this angle right here. Okay, so what we're inputting into the sine function is the angle. It's equal to the length of the side opposite theta, okay, which is A, divided by the length of the hypotenuse, C. Then we have cosine of theta, okay. Cosine is the length of the side adjacent to angle theta, which is B, divided by the length of the hypotenuse here, which is C. So it's just B divided by C. And then the tangent of theta is the length of the opposite side, the length of the side opposite angle theta, which is A, divided by the length of the side adjacent to angle theta, which is B. Okay, so it's just A over B. And there's kind of a silly saying to help you remember this. If you've ever heard of SOHCAHTOA, And there's this saying to go along with it. Some old horse caught another horse taking oats away. So sine is opposite over hypotenuse, Cosine is adjacent over hypotenuse. And tangent, t, is opposite over adjacent. Sokatoa, some old horse caught another horse taking oats away. I know it's silly, but you'll hear me say this a few times in the coming weeks, in the coming lectures. Okay, so in general, the trigonometric functions of theta depend only on the size of the angle theta, not the size of the triangle. Okay, that's really important to know. So it only depends on whatever the angle is. Okay, so then we have the other ones. So we have cosecant, which is the length of the hypotenuse divided by the length of the side opposite angle theta, which is c over a. Okay, another way to think about this, c over a, it's the reciprocal. Notice it's the reciprocal of sine. More on that later. Secant of theta, okay, that's the length of the hypotenuse c, all right, divided by the length of the side adjacent to angle theta. That's b, so that's c over b. And then cotangent of theta, okay, that's equal to length of side adjacent to angle theta divided by the length of side opposite angle theta, b over a. And look, secant of theta, c over b, it's the reciprocal of b over c right here. And the same thing with b over a, cotangent, looks like it's the reciprocal of tangent. So more on that later. All right, so let's begin by now starting to illustrate some examples here, okay, of how you're going to use this with right triangle trig or evaluating these functions. Okay, so I've got this triangle here, and it says find the value of the 6 trigonometric figure functions in this figure. So I have, again, going back, look, I have my ABC, and then I have CAB, an angle theta, and now I'm just putting numbers to them. All right, so the first thing is you got to find the value of C. And so you're going to use the Pythagorean theorem here. So find the value of C using a squared plus b squared is equal to c squared. So this is 3 squared plus 4 squared is equal to c squared. So this is 9 plus 16 is equal to c squared. 25 is equal to c squared. So when you take the square root here, obviously c is going to be equal to positive 5. You can reject the negative 5 here, right? Because the length of a side of a triangle has to be positive. Okay, so then let's go through this. Sine of theta here. It's going to be the opposite side over the hypotenuse. Okay, so sine is the opposite, so that's a, going back, a over c, over the hypotenuse, which is c. So the sine is just 3/5. Cosine of theta. Okay, that's going to be the adjacent side over the hypotenuse, which is b over c. So look, here's theta. So adjacent to it is b, and c is the hypotenuse, which is 5. So this is just 4/5. And then tangent. Remember my silly saying, some old horse caught another horse taking, so it's oats opposite over adjacent, away. So tangent. I wrote TOA. Tangent of theta. So it's opposite side, so that's 3 over adjacent, which is 4. Okay, so then next we have cosecant of theta. All right, so looking back, what is cosecant defined as? It's hypotenuse over opposite, c over a. Well, look, it's just reciprocal of this, so it's just 5/3. Then we have secant of theta. Secant of theta is the hypotenuse over the adjacent. So going back to length of the hypotenuse over length of the adjacent side, c over b. So this is just 5 over 4. And then cotangent, okay, that's just the adjacent over the hypotenuse, right? So looking back, it's length of the adjacent side over the length of the opposite side. So that's just 4/3. Boom, we got it. Okay. So you can see here that the trick was just, you know, remembering the definitions and then going from there. Okay. Let's try another one. Let's find the value of the 6 trigonometric functions in this figure here. Okay. So right off the bat, okay, this is C. So this is my hypotenuse. Boom, right here, okay? This is the side opposite B. So we got to figure out what A is. So again, to find the value of A, what you're going to have to do here is you're going to have to use the Pythagorean theorem. So it's A squared plus B squared is equal to C squared. Okay. So look, A squared plus 21 squared is equal to C squared, which is 35 squared. So you're gonna have to grab your trusty calculator here for this, right? So look, I'm just gonna subtract the 21 squared over. So 35 squared minus 21 squared gets you 784. So A squared is equal to 784. And then when you take the square root of that, right? You get 28. Okay, so I found the length of side A here. All right, so let's go through the process, right? So sine of theta. That's the opposite over the hypotenuse. So here's theta. So the opposite is A, which is 28 over the hypotenuse, which is C, which is 35. Cosine of theta is the adjacent length over the hypotenuse. All right, so adjacent to angle theta is 21, right, over 35. And tangent is the opposite over the adjacent. So tangent would be 28 over 21. Just like that. And then look, now you can find the other ones here, okay? Cosecant of theta is equal to the hypotenuse over the opposite side, which is just 35 over 28. Again, you can see it's just the reciprocal of this. Secant of theta, that is the hypotenuse over the adjacent side, which is 35 over 21, again, the reciprocal of cosine. And then 6 cotangent of theta, that's just the adjacent over the opposite, which is just 21 over 28. Okay, so a little, a little obscure so far, but we don't even know what theta is. All right. Eventually, I'll show you, like, once you have triangles like this, how you can use this stuff to help you find theta. But for now, we're starting to build here. All right, so let's work some other stuff here, okay? So I want to talk about function values for some special angles here, so for some special triangles that come up quite often. So a right triangle with a 45-degree or pi over 4 radian angle is an isosceles. That means it has two sides of equal length. So what that means is when you want to set this up, okay, if you just know the angle, all right, look what this means, right? One side you could say is equal to 1. The two sides have to be equal length. And then using the Pythagorean theorem, okay, what that means is the hypotenuse here, if the sides are length 1, okay, that means the hypotenuse has to be the square root of 2. All right, let's look at another one here. There's something called a 30, 60, 90, okay, triangle. So a right triangle that has a 30 degree or pi over 6 radian angle also has a 60 degree or pi over 3 radian angle. So in a 30-60 triangle, the measure of the opposite side, the side opposite the 30 degree angle is 1/2 the measure of the hypotenuse. Okay, so to set it up this way, this is how you would set up the triangle. Here's the 30 degree angle. Okay, we're going to have its length be equal to 1, which means the hypotenuse is 2. Okay, because the length here is 1/2 the hypotenuse. So then that means the length of the side opposite the 60 degree angle, if we have this side be 1, is going to be equal to the square root of 3. Okay, so keep these triangles handy because I'm going to ask you some questions now from this. All right, so let's use this figure here. So I have an isosceles triangle to find the following. What is cosecant of 45 degrees? What is secant of 45 degrees? And what is cotangent of 45 degrees? All right, well, you have to just look back and say, okay, how is cosecant defined, right? So look, cosecant is hypotenuse over the opposite side. Well, look here. Here's 45 degrees. Okay, the hypotenuse is the square root of 2, and the opposite side is just 1. So look, cosine of 45 degrees is just going to be the square root of 2. All right, secant, looking back, how this is defined. Secant is hypotenuse over adjacent. Well, the hypotenuse is the square root of 2. And the adjacent side here is 1. Yeah, so this is also the square root of 2. So this right here, cotangent of 45, is going to be adjacent over opposite. So you can see here adjacent over opposite. Well, adjacent is 1. Opposite is 1, so this is actually 1 over 1, which is just 1. All right, so let's work one now with a 30, 60, 90. Okay, so use the figure here. Okay, I've got the 30, 60, 90 triangle set up to find tangent of 60. And then also tangent of 30 degrees. All right, so what is tangent? Tangent is opposite over adjacent. And then it also says to rationalize the denominator as needed. All right, so here's 60, right? What is the opposite 60? Square root of 3. What is the adjacent? 1. So this is just the square root of 3. Now here's 30 degrees, okay? What is the opposite to 30? It's 1. What is the adjacent? It's the square root of 3. So then here you just have to rationalize this denominator, right? And so, hopefully remember how to do that. So this just becomes the square root of 3 over 3. All right, so we're getting there. We're figuring it out. All right, so now here I then talked about some of the fundamental identities. I've been kind of hinting at these, okay? And so there's something called the reciprocal identities and the quotient identities. So the reciprocal identities, sine is equal to 1 over cosecant theta. And then also cosecant theta is equal to 1 over sine. I kind of hinted at that. Cosine is going to be equal to 1 over secant of theta, and secant is equal to 1 over cosine of theta. And then tangent of theta here is equal to 1 over cotangent, or cotangent of theta is equal to 1 over tangent. So you can see these are reciprocals of each other. Next, we have what's called the quotient identities. Okay? And it turns out that tangent of theta is equal to sine of theta divided by cosine of theta. And then since cotangent is the reciprocal of tangent, cotangent of theta is equal to cosine divided by sine of theta. All right. It really would behoove you to memorize these, as you go through, especially if you're going to continue on and take calculus. Like, these reciprocal and quotient identities are incredibly important. All right, so let's do this. Use the quotient and reciprocal identities, and you're given the following. Sine of theta is equal to 2/3, and cosine of theta is equal to the square root of 5 over 3. It says find the value of each of the 4 remaining trig functions. Okay, let's start out with tangent. That's equal to sine of theta over cosine of theta. Well, that's 2/3 over the square root of 5 over 3. Keep, change, flip. That's 2/3 times 3 over the square root of 5. 3's cancel. And this is 2 over the square root of 5, or when you rationalize the denominator, this is 2 square roots of 5 over 5. That's tangent. All right, so let's go back. Now let's use cosecant here. Okay, so we know cosecant of theta is equal to 1 over sine of theta. Well, that's 1 divided by 2/3. Keep, change, flip. This is just 3/2. Secant of theta, that's 1 over cosine of theta. That's 1 divided by the square root of 5 over 3. Keep, change, flip, right? So this becomes 3 over the square root of 5. And then rationalizing the denominator here, that's 3 square roots of 5 over 5. And then finally, cotangent of theta. What is cotangent of theta? Cotangent of theta is just 1 over tangent. Okay, and look, tangent was down here, so this is 1 divided by 2 square roots of 5 divided by 5. Keep, change, flip. And so when you rationalize the denominator here, you get 5 square roots of 5, 2 times 5. Well, the 5's will cancel. And you're just left with the square root of 5 over 2. So what you're seeing here is when you're given, sine and cosine here, you can use it to find the other trig functions. Okay. Next, we have what are called the Pythagorean identities. And so we have the following. It turns out that sine squared of theta plus cosine squared of theta will always be equal to 1. Next, you have 1 plus tangent squared of theta. That will always be equal to secant squared of theta. And then 1 plus cotangent squared of theta will always be equal to cosecant squared of theta. All right, let's work an example here using one of these Pythagorean identities. Given that sine of theta is equal to 1/2 and theta is an acute angle, find the value of cosine of theta using a trigonometric identity. Well, look, I want to find the value of cosine of theta when I know sine. Boom, right here. If I know sine, I can figure out cosine. All right, so I'm going to use sine squared of theta. It's important to note, and let me go back here, that this right here, when you see this, okay, what this means is this means sine of theta squared, okay? They just put the squared here with trig function. So cosine squared of theta, that's equal to cosine of theta squared. It's just a way of saying it, okay? Tangent, and it's the same for all of them, Okay, tangent squared of theta, that's equal to tangent of theta squared. They just, instead of writing it like this, they just put the squared there. Same with secant, cotangent, and cosecant. Okay? So sine squared of theta plus cosine squared of theta has to be equal to 1. Well, we know sine is equal to 1/2. So this is 1/2 squared plus cosine squared of theta is equal to 1. Well, 1/2 squared is 1/4 plus cosine squared of theta is equal to 1. So you're going to subtract the 1/4 over. Those cancel. I'm going to move over here. So I have cosine squared of theta. 1 minus 1/4 gets me 3/4. And then just to get rid of the square, all you're going to do is you're going to take the square root of both sides. Square and square root cancel. You're left with cosine of theta is equal to the square root of 3, and then the square root of 4 is 2. And here, normally we would say you would get two solutions, one positive and one negative. This is the important part that'll get covered in a later slide. Because I'm saying theta is an acute angle, what that's telling me is cosine is going to be positive here, and that'll get explained in another lecture in a little bit. Okay, so let's now now that we kind of worked an example with this Pythagorean identity, let's now talk about how you're going to use your calculator to evaluate trigonometric functions. Okay, so as we go through this, have your graphing calculator handy here, and you see here right on your calculator, you see that it has sine, cosine, and tangent. Now, I want to note here that this sine -1 does not mean 1 over sine. Okay, so that's really important. This is the inverse sine function, and we'll talk about the inverse sine, inverse cosine, and inverse tangent at a different time. Okay, so to evaluate trigonometric function, we use the keys on a calculator that mark sine, cosine, and tangent. Okay, now this is important. All right, be sure that to set the mode to degrees or radians depending on the function that you are evaluating. So you might need to consult your manual on how to do this. I'm going to show you how to do this on the TI 84 here that I have. Okay, so let's find these. So I want to evaluate to 4 decimal places sine, whatever sine is, of 72.8 degrees. Now, if you look here on your TI 84, there's this button that says mode. And if you scroll down, there's something called radians. So it starts off in radians, and I'm going to go over and click to set it to degrees. Now I'm going to go sine, and all I have to do is type in 72.8, close the parentheses. And look here, it's 0.9553. So 0.9553. Now cosecant of 1.5. So now it's in radians. All right, what is cosecant? You're going to have to do this as 1 over sine of 1.5. So you're going to have to use the reciprocal function here, or the reciprocal identity. So you're going to have to go back to mode and put it in radian. All right, so then you're going to have to go 1 divided by sine. Now that it's in radians, I could put in 1.5. And look, it's 1.0025. All right, make sure, because if I had plugged this in, I'm just going to show you wrong here. If I had plugged this in while it was in degrees, I get such a different answer, right? So you have to make sure that you have it correct. If it's in, you got to make sure you have it correct here if it's in radians or degrees. Okay. Let's talk about how you find some measures here using trigonometry, right triangle trig. And then at the end here, we're gonna add it together and do some application problems here. All right. So it says, find the measure of the side of the right triangle whose length is designated by the lowercase letter. Okay, so here I'm asking you to find A here. Okay. So notice you're given the adjacent and the opposite. Okay, and you get told this is at 37 degrees. Well, isn't tangent of theta equal to the opposite length over the adjacent length? Well, look here. What I'm saying here then is tangent of 37 degrees must be equal to the opposite, A, which is what we're trying to find, divided by 250 centimeters. So then just cross multiplying here, you can see that A is equal to 250 centimeters times tangent of 37 degrees. All right, make sure your calculator now is in degrees, which it is. And you're just going to take 250 times tangent of 37. And look, what I'm saying here is A is, and I'll go to 2 decimal places, is 188.39 centimeters. Let's try this one here. So I've got the angle, and then I've got the side opposite and the hypotenuse. Well, isn't sine of theta equal to the opposite divided by the hypotenuse? Yes. Yes. So sine of 23 degrees must be equal to 16 meters divided by c. So look, cross multiply here to solve. So c times sine of 23 degrees is equal to 16 meters. Then divide by sine of 23. And let's see what we get. So I'm going to take 16 divided by sine of 23 because I'm in degrees. And look, it's going to be roughly 40.95, all right, meters. All right, so now I want to take these basic concepts here and work some application problems from this now. All right, so here's going to be our first application problem. The irregular blue shape in the figure here represents a lake. Okay, so I have this lake here. The distance across the lake A is unknown. I want to figure that out. Okay, to find this distance, what a surveyor did, he or she did, she took the measurements shown in this figure. So basically they went to here on the lake, they walked over here and they said, okay, that's 750 meters. And then they measured the angle to the end of the lake here. And that was a 24-degree angle. Okay, and they said, well, how what is the length of this lake? Well, look, this triangle here looks exactly like what we did here, and it involved using tangent. So tangent of theta is equal to the opposite length over the adjacent length. So tangent of 24 degrees is equal to A, what we're looking for, over 750 yards. So cross multiply here, and you see A is equal to 750 yards times tangent of 24 degrees. Well, grab your calculator. $750 times tangent of 24. And look, what we're saying here is the length of this lake here, okay? And I'm going to round it to 2 decimal points, is 333.92 yards. Okay, let's try another one. So, you've seen some applications here of trig, which is great. So a plane rises from takeoff and flies at an angle of 10 degrees. So it's taking off and it's flying at an angle of inclination here of 10 degrees. All right, with the horizontal runway. When it has gained 500 feet, find the distance to the nearest foot the plane has flown. Okay, so I'm asking you to find the hypotenuse here, this C. So look, this problem looks a lot like this. So its sine is equal to, sine is the opposite over the hypotenuse. So sine of 10 degrees is equal to the opposite, so it's 500 feet in the air, divided by C. That's what we're looking for. Cross multiply. So C times sine of 10 degrees is equal to 500 feet. Divide by sine of 10 degrees. And let's see roughly how far the plane is flown. And I'll go 2 decimal places again. So it's flown roughly 2,879.39 feet. All right, class. I know there was a lot to cover in here with this right triangle trig, but we're going to continue to practice with this in the coming weeks. And as always, if you need anything, please let me know.